Welcome back, guys. In a series of finding marginal rate of substitution for different types of utility function, now is the time to find out the marginal rate of substitution for a linear utility function. If you have a linear utility function with a general form, which is u, or a utility function which is a function of x and y, is equal to ax plus by. ax plus by. So now, what is the marginal rate of substitution for this linear utility function? We know the general formula, which is the marginal rate of substitution is equal to marginal utility of x divided by the marginal utility of y, and this is equal to the partial derivative of utility with respect to x and the partial derivative of utility with respect to y. So now let's find out. So for the case of linear utility function, it's very easy to find out the partial derivative. So now the partial derivative of this utility function ax plus by with respect to x is equal to simply just is equal to a, because the partial derivative of this part with respect to x is just equal to a, and the partial derivative of this part with respect to x is equal to just 0, because we don't have an x value here. So now the partial derivative of utility function with respect to y, so the derivative of this part with respect to y is equal to 0. So then the derivative of this part with respect to y is equal to b. So simply, the marginal rate of substitution for a linear utility function is the ratio of coefficients of x and y. The ratio of coefficients of x and y. So what value a and b takes, then the marginal rate of substitution will take the value of ratio of that one. So then, finally, the marginal rate of substitution is equal to a divided by b. So this is the final solution. So it depends on the value of a and b. For example, if we have our utility function such that like this, uxy is equal to 2x plus 4y. 2x plus 4y. Based on this formula, which marginal rate of substitution is equal to a divided by b, then it will be equal to 2 divided by 4, which is 1 over 2, or 0.5. And also if we have this utility function u of xy, which is equal to, for example, 6x plus 3y, then for this one the marginal rate of substitution again MRS is equal to a divided by b and equal to 6 divided by 3, 1, 2 is equal to 2. So then you see that the marginal rate of substitution for a linear utility function is just a constant number, and this constant number comes from the ratio of a and b. So simply, in the case of linear utility function, our marginal rate of substitution does not depend on how many x and y goods and services we have in our consumption bundle. Rather, it just depends on the value of a and b. Why is that? Because for the linear utility function, we have just a linear indifference curve. So this is x, this is y. This indifference curve for the case of linear utility function is equal to a linear curve. So when it's linear, so the slope of this linear curve is constant along the line. Whether you move from this part to this part or this part to this part, the value or the slope of this part and the slope of this part is completely equal to each other. There's no difference because it's a linear. It's not non-linear. If it's non-linear, so the case will be different, as we have for the case of Cobb-Douglas and CS utility function. But here, because the slope is equal in every point of this indifference curve, then the marginal rate of substitution should be a constant number, which comes from the ratio of the coefficients of x and y. So this is as simple as it is. for finding the marginal rate of substitution for a linear utility function. I hope to see you guys in the next video. Thank you so much for watching. See you next time.